Okay, so the topic we're going to cover from Cisco CCNA. As you all know about CCNA, which is the first technical certification, professional certification, or career certification from Cisco, which is called CCNA, Cisco Certified Network Associate. The exam number 200-301. Hope I'm audible. So these are the major topics we're going to cover from Cisco CCNA. Out of it, the network funda is the common topic for any vendor, any platform. Rest all, the logic and the concept are somehow equal for any platform. But when it comes to a configuration perspective, the command are some sort of difference from each vendor. Okay, so we'll start from the very basics. So once you clear the certification after the course, you're gonna get a certification for 3 years. Here, the entire Cisco syllabus has been divided into two. We are into infrastructure engineers. There is a software developments, which is DevOps. So under the infrastructure engineers, which we're going to cover Cisco CCNA. Give me a moment. Okay. So from the infrastructure engineers, Cisco, the career certification track in this way, like start from CCNA, which is a single paper. Then in CCNP, we have multiple track. Each track will have multiple papers plus the expert paper. Okay, so once we covered CCNA, the enterprises talk about routing and switching. The rest is equivalent to their own names. Like example, security talk about firewall. Then collaboration talk about IP telephony. And on top, there is a equivalent to expert or CCI certification on the same track. So from CCNA, we will be covering about the major area from each track in a minimum skills. So once you clear the certifications, you're gonna get the certification for next to 3 years validity. It will be mentioned about valid until on which date. Then before the expiry of a current certification, like example CCNA, you have to clear another exam. Example, this was on 2019 where they had the CCNA security, now they stopped. Now there is only a single CCNA. Then if you go for any higher certification, before expiring the existing one, you will be getting a new certification with a new date plus the existing certification you're going to get again as a soft copy from the Cisco portal with the latest date. So you need to keep in mind before your certification going to be an expiry, you have to try clearing the higher exams to maintain all your certifications. Once if any certification is expired, it's going to be inactive. Then to get it active, you have to clear it from the beginning. Okay, these are different certifications. We'll talk about certification in detail about later. Okay, so these are the track about engineering and software. So we are currently into engineering with the CCNA certified. So once certified, then you can go for CCNP. In CCNP, there's a core paper. Once you clear core paper, you will get the specialist certification. Then again, if you clear any other certification within the window, like in CCNP routing and switching or enterprise will have more than 6-7 certifications. Other than core, if you clear any one of the certification, like a minimum 2 in CCNP track, you're gonna get the CCNP certifications, which is you're completely CCNP certified into that domain. Okay, this is all about the basics certification track. So we can focus on CCNA at the moment. Now, some of the basics are very equivalent to all of us, which we already knows or hear about the basic structure. Okay. So once we learned about networking, You can see one diagram I have defined here. This is our ultimate goal, to understand how this diagram looks and how we can implement. So the basic networking infrastructure, talking about what is networking, what is computer networking. So basically, you guys hear about to connect between devices, we're gonna call in a general terms about networking. Okay, it could be between computers, I mean, between desktop, between laptop, or uh, between phone to phone, or between any equipments to equipment, communicating between them for transferring or sending and receiving a data. That's the ultimate goal of making networks. So here, when you do networking, we have a multiple options. Either you can do two computer directly with a single cable without having any extra device, just a UTP cable, if it's a copper communication. If you have more than one devices or two devices to be making them under one network, then you need to follow either a wired solution or wireless solution. There are two basically. When you talk about wired, a central equipment should connect to all other devices through a cable. The central equipment we generally called as switch. We'll talk about detail in later. If it's a wireless, again, the central equipment should have a capacity to understand about the Wi-Fi technologies, and the receiver should have a capacity to listen and receive it. So it's somehow we call it as a Wi-Fi uh, technologies. Okay, we will talk about this as well as a later. So the ultimate goal to understand your network should be a combination of either complete wired. What does it mean? You're going to get the internet to your home or to your office, and that will be connected to your modem. Then you will be connecting to a central device, either it called a switch or wireless router. From there, depends on the available ports on that device, we're going to connect to the respective destination devices. It could be your computer, it could be any other devices. So basically, this all the basic frame funda you might heard about. That's why I'm giving a very simple uh, explanation. So if you have any doubt, you can ask in between. And the same technology you could also have through wireless, where you end devices will have something called SSID, that you can get it from your computer or your mobile to see what name it is. That name is reflected from your wireless central devices. We used to call it as a controller. Or you could have a complete Wi-Fi or complete wired, or it is mixed. It depends. We'll write the diagram. And the basic network funda, which you will be able to understand as a minimum skills, that this is your network design. Okay. So you guys might have gone through this. Okay, let me give you a brief explanation. In any network infrastructure, the minimum requirement that you or the end user will have the end device connectivity. So our first primary questions to them: on what purpose you need a network implementation? To connect your CCTV camera, BMS, access control system, or just a laptop, desktop, I mean the user computers or telephone. We must need to know the exact requirements of the end user first. Okay, let's say they're going to tell us, I do have computers, phone, printers, CCTV, all depends. They're going to give details. Then all your edge devices, it could be anything like a computer, laptop, desktop, camera, whatever it is. All your edge devices are generally connecting to a switch called access switch. The access switch is not the physical name, that is the depends on their services. We used to call access switch. So your internet will be coming to your office, that can be connected to a switch where your switch has your end devices. A simple design. Or the internet, you can connect it to the main switch, and the main switch can connect it to your access switch. Another scenario. In this case, the main switch, we call it as a core switch, the central switch. Okay, let me give you a diagram. Any question?
Go ahead, go ahead.
Okay.
Thank you.
Hope you can see my screen. Here you have computer. So basically, in the network infrastructure, we used to do 2, 3, 4 tier architecture. Minimum 2 or 3 or 4 tier architecture. So in every implementation, we will have access switch where your computer connecting to. Then you will have a core switch where your outside connection coming into. Example, you have QTEL internet, which is Orido coming to your office, and it is connected to ISP device, which is usually it's Huawei device. Then either that can be connected to your main switch, or in somehow we will be having a security product called firewall connecting into a firewall. The firewall or the major equipments connecting to the room, we call it as a MDF room, or we call it as a data center room, which is a main room for the entire design. And generally, we will have 2 core switch. And when you have 2 devices for the same purpose, we will be interconnecting between them, making as a single architecture. There are multiple names for that. One of the name we call it as a VSS or stack or VPC. There are many names. So the ultimate goal to make a 2 switch as a one group for the redundancy purpose. Then either we will have a single leg to one switch, or we will have a double leg to a 2 switch for the redundancy purpose from the outside connectivity. And we have a one access switch. The access switch are located the place or the room, we call it as an IDF room. Let's say IDF 1, which is located in ground floor. Depends on my edge connectivity, we will be defined what type of switch that I need. Example, if I have, let's say, nearly 20 user to be connected to this IDF, which means to this switch, we will be either 24 port switch or 48 port switch. It depends upon the number of requirements. Let's say I have a single switch here connected to my edge device. I have another IDF, let's say IDF2. Here I have another requirements where I have a more ports. Let's say I have 60 connections. When I have more than 48, I can even look about two switch together. Like let's say 30 connection to this switch and 30 connections to this switch to get total 60. So again, when you have two switch in one IDF, we have a multiple set of design. One of the easiest and the best design, or the best practice to make them as a one. I'll let you know why to make them as a one. Now, I have a phone, I have a PC. When you have a two device, either you can connect phone on a separate cable, PC on a separate cable. Basically, the PC and the phone for one user. So instead of utilizing two cable with the two ports, I can use a single port connecting to a phone, and the phone will have two ports. On the back side, we can connect directly to the PC. Hope you can understand. Can you see me? Okay. You can see the switch. Basically, this is a Cisco switch. Okay, Cisco 2960. And the switch, you can see a hole. Okay, this hole we call it as a ports. Okay, in this switch, you can see there are 12, then 12. So total we have 24 ports in this switch. Okay, now I do have another switch, which is from, you can see the model where you can you read the model? It's an extreme networks. Okay, here you can see 12, 12, 12, and 12, which is 48 ports switch. So when you say a 48 port switch, all the 48 ports are for downlink, starting from port number 1 towards to here until port number 24 until here. This ports we call it as a downlink. The downlink is always used to connect to your edge devices. It could be your telephone, PC, or uh, camera or APU whatsoever. So then you can see a few more ports here. Okay, this ports is generally we call it as a uplink. You can see here 1, 2, 3, 4. Then again you can see 5, 6. There are 6 ports here, which is called uplink port. And close to this you can see one port, this one, which is written as a console. This is for configuring the switch. And beneath you can see one more port, which is called USB port. The USB port is generally used to connect the USB pen drive to upgrade your switch by having images. Same way, if you look into this switch, You can see the console port on behind the switch, connecting the console cable for configuring the switch. And in the front, it's a 24 port switch. So all the 24 ports are downlink connected to your edge devices. Then you can see the two more ports, which is higher speed than this. Let's say if this is 100 Mbps ports, each ports, then this is 1000 Mbps. If this is 1000 Mbps and this is 10,000 Mbps, which we call it as a 10G. Uplink port is always higher speed than the uh, downlink ports. Okay, hope you understand. Now, you can see a Cisco phone, okay? And generally, we're gonna connect a cable from the switch to, you can see behind there are ports. Here you can see the ports, which is, there are two ports. There are three ports, by the way, I mean, one for connecting to the, uh, it's a RJ11 connection. The other two ports, which is defined as Ethernet port. So what we generally do, one port connecting from switch to the phone, and the other port from the phone to the PC. So by having a single cable, single ports from each switch, the one port can utilize for the phone and from behind phone to the PC. So we don't need a two individual port for each users. Any doubts?
Fine. Okay.
Okay, okay.
Yeah. So now here you can see the edge devices are connected to the switch, which is called access switch. Okay. Now between access switch to the core switch, what is core switch? Core switch is the central switch where you have all outside connectivity and intercommunication between all other networks. Today, I'm just giving you an overview of the basic infrastructure, and we will talk about each topic in individual. Now, you want to connect between your IDF and your MDF, which means from your access switch to your core switch. Let's say this is 48 port switch. In this 48 port, until starting from port number 1 until 48, these all are your downlink connecting to your edge device. And in the same switch, you can see an additional port, which we call it as an uplink. These uplink generally either copper or fiber. Nowadays, majority design is consuming fiber connections. Let's say you have 1, 2, 3, 4 fiber ports. Okay, and you have a 2-core switch. So this generally the first IDF, the plan is in a way that the first IDF connecting to first port of your core switch, which is called 1/1. This one representing the port number, this one representing the first switch in the easiest way. And we connecting the second port, go into the second switch. The best practice is connecting here as well with the same port 1. But this start number with the 2, the reason the second switch. and we'll make them one group. Okay. Now, the second connection from your second switch, second IDF, it's number 2. So we'll connect a second cable to, let's say, this is for, let's say, 24, 24. Okay, it's a 48, 48. Let's say until here is a 48. And we have a fiber here, one connected to here. And this is 1/1. First to switch, first port. First switch, second port. The first port already consumed. Now we have another switch. So we can connect it to the second switch, first port. Connecting to second switch. So this is second port, second switch. First port, second switch. So if this goes down, you have an alternate link to go up. And we'll make them a bind. Okay, so always when you have multiple switches, we will have a dual connectivity. So the ultimate idea that you have a core switch, you have an access switch, and you must need a connectivity between them. And 99% design would be fiber connection rather than copper connectivity. So you have an access switch, you have a core switch. Now you have a telephone here. This telephone should require a server, right? In a smallest design, if it's a Cisco phone, we used to call Cisco CM or CUCM, Cisco Unified Call Manager, where all your telephone number, calling privileges, and all other related phone information's being recorded or configured in the server. So that's going to be connected to one of your core switch. Maybe if your call manager has 2 ports, then we generally do with connecting one connection into first switch and second connection into second switch with a NIC1 and NIC2 for redundancy purpose. And this is in the call manager side, we used to call NIC teaming.
Excuse me.
Yeah,
Call manager means it's a
call manager
PBX.
in the sense, yeah, PBX.
PBX. Okay.
Yeah,
Any
Avaya,
any PBX.
any PBX, but generally the normal PBX will have a single cable, single connectivity.
Yeah. Single cable. Yes.
Okay, in this case, we used to connect with a single switch only.
Okay. Okay.
And
Fine.
let's say you have access points, AP, for boosting the signal to use a user to get Wi-Fi. It's called access points. Access points by itself cannot do anything. It's just the boosting. It gives a 20-meter somehow coverage each AP. To get the signal for the AP should get instruction from the central product called WLC, wireless LAN controller. It's a physical equipments. So you can see here, this number is 200, the model number from, you can see this from Aruba. This is one of the controller, which very old controller. So let's say either you must need a central controller, or one AP can be act as a controller, or you can use an image into a virtual machine platform to make that virtual machine as your controller. Anyhow, you must need a one central controller to provide instructions to AP to act. So this controller will be connecting into your core switch. Now here we have a core switch, access switch, only 2-tier design, minimum base design. If your WLC will have a 2 ports and there's a free port on the other switch, Then for the best redundancy purpose, what even can do, will have a connection from your one port to first WLC and second port from the same WLC to a second switch and make them a group for high speed and redundancy. If your switch doesn't have an extra port or your WLC doesn't support an extra port, then there is no point. And I have seen in some of the design, when you have an access point, the access point also have a two port connecting to two switch and make them one group. Everywhere we will try to make them dual connectivity for the extra redundancy purpose. In any connection that you have in your edge devices should require a central server. Example, you have a PC here, right? If the PC is under domain, your PC should get instruction from your domain, which is example, we call it as a Office 365 or Azure directory, I mean Active Directory from the Azure cloud, Microsoft cloud. So this Azure is in your cloud after your internet. So this gonna pass in this way to go to there. Or you might heard about DHCP server for providing IP address to all your edge computers. In this case, your DHCP is a server, should be somewhere in your high-end network, which is under your MDF. So in a shortest way that you must need edge device